Welcome back to CNC Equipment's YouTube channel. Area Diesel Services YouTube channel. Today, we've got another collaborative content with our friends over at CNC Equipment. The boys at CNC reached out and they're kind of looking for a power package type solution. They've got a first gen Dodge, so the boys over there are going to pull the engine out of the first gen and they're going to drop it in this beautiful Ford truck. They want to try and see if we can bring this old 12 valve to life. Area Diesel Service is going to take care of injection pump, fuel injectors, and turbocharging on this engine transplant and performance upgrade. We have the VE Bosch rotary style pump here in front of us. This is the pump that Clint and Kevin pulled off the engine. This is step one of what Area Diesel Service is going to do for this project. Pop this dude open, take a look. This was a running, functioning engine. And I think they've got the engine on the stand now. I believe they're just going to do a kind of a reseal, clean up, put it back together. I don't think we're getting into full engine overhaul. Here's the pump. They want working class performance upgrade solution. They want it to be reliable. Again, Bosch VE style injection pump, 6-cylinder Bosch rotary pump. This one specifically is a 0460-426-205 or Cummins number 392-3346. First gen 12 valve. These trucks were in the 180 or so horsepower range. When we first started talking to Clint, he was hoping to get up closer to about 350. While we can do that, to get there to that level of power out of this pump requires a head and rotor modification, or basically an upgrade to what is a non-genuine Bosch part. It's a performance part, and we were just a little bit reluctant to put that in this pump and call it a reliable daily driver. We discussed the options with Clint, and he opted for us to go through this pump, do the common fuel pin upgrade and the other tunes and tweaks so we can get maximum delivery out of this, retain that drivability, reliability, and safe, conservative horsepower. You know, we're probably talking 275 is kind of our goal for delivery on this thing. And the other thing, Clint wants to go to a straight mechanical shutoff. This pump is equipped with an electric shutoff. So we're going to take that and disable the electric shutoff, and then we'll just go to the straight mechanical lever on the side of the pump for shutdown. If you didn't arrive at this video from Clint's channel, please be sure to go over there, tell them that we sent you. Boys over there do some awesome projects, a lot of construction equipment, souping up pickup trucks, Jeeps, all kinds of neat stuff. We'll definitely give you some updates as we progress through this pump, and then when we get back up to the parts counter, we'll review what we're going to come up with for turbocharger and for fuel injectors. So we'll bring you back. Step one complete. So this is Clint's pump. We brought it into the teardown shop. We washed it up in the pressure blast cabinet, took it to the abrasive cabinet, sandblasted it before disassembling, blew it off, brought it over to the teardown bench, and we've got this thing scattered. As suspected, this pump is in fantastic condition, right? This was a running, functioning engine. Everything inside looks to be in very good conditions. Noteworthy, possibly at this time, this is the component that we're going to upgrade, which will provide the increase in horsepower. That component, along with this spring, which dictates governed engine speed, will also get replaced. This is the shutoff solenoid, and Clint wants to go to a straight mechanical shutdown. This is an electromagnetic electric shutoff with the key. We're going to pull the guts out of that, so he just has a shutoff with the lever. We're going to go through standard rebuild procedure. Next step from here, take all of the individual parts over to the solvent tank, make sure we've got a thoroughly clean component, all of the subcomponents, and then we'll throw away what is junk or scrap, take the good parts back up to the buildup room. We'll put this thing back together. We'll do some calibrating to get the increase in fuel delivery along with the fuel pin, and we'll calibrate, paint, and get this thing shipped back out. We're in the buildup room. We've got the base pump reassembled and rebuilt, ready to go. There'll be some calibration adjustments within the base pump to obtain the increase in power, but effectively everything here down is stock. Top cover aneroid housing is where the fuel control rod is going to be changed. So you can see this is the stock rod, this is the aftermarket performance rod, and what we're seeing is basically a difference in the ramp. This rod goes into this housing like so, and there are some levers in the bottom of this housing. This is shut off here, and this is fuel control here. Those levers line up with the fulcrum, these components here. This spring is an aftermarket spring. That's engine governed speed, so we're increasing speed, and then we're also changing the profile of this pin, which changes the way that the fulcrum is allowed to move inside the pump, allowing more travel at a different time. Along with the other calibrations is how we're going to get the increase in fuel delivery. We did gut the shutoff solenoid, so it's just there basically as a dummy plug at this point. The control rod gets a new diaphragm, goes in the housing here, and we'll put all this stuff back together, and you'll see on the stand we're going to feed this thing. This is boost, this is sensing boost, right? So boost is operating on this diaphragm. The spec calls for about 1,000 HPA, which is about 14.5 pounds of boost pressure. So we're going to boost this engine beyond 14.5 pounds, but anything beyond 14.5 pounds will be maxed out for fuel here. We'll give you a little bit of footage slapping this dude back together, and then we'll meet you at the test stand. We'll get this thing calibrated and move it on throughout the process. So
okay, so that shaft's connected to your extension governor spring that we just replaced and put a higher RPM spring in.
This?
Yes, so as you turn that, you should be able to feel tension on it. If you look down inside that hole, when this has tension on it, it'll push that rod against that, out of that little hole down in there. Which vice versa in turn gives you more horsepower.
So is that throttle?
Yes. So we'll make those tight. I normally keep tension against that, and then you can kind of push on that rod down in there. You want that rod to be nice and free, because if it's stuck, it won't operate right. So we got a spring that goes in there, got a spacer that sits in there. There's a dot on the top of this, so that's where I kind of line the center of this up with. That's where that pin's actually going to ride. Just take this, put your 4 screws in it, tighten it down.
So the pin and the spring is really a modification you could make on engine.
Yes, that's what this kit's actually made to do. When you buy it, it does got step-by-step instructions on how to do it on the engine. Really, it's not bad, I guess. But then again, anything on an engine can turn south pretty quick.
It's pretty pleasant here on the bench.
Yeah.
Laying over a core support.
That's right. Okay. Other than that, we'll just put our throttle levers on and be in the test room.
So we are to the point in this process where we're going to calibrate this pump. This is Clint's pump, and we've got her chucked up on the Hartridge AVM2 PC. This is the stand that we use to run our VE pumps on. We're going to kind of walk you through the process. You may have seen some of this before. So there's a motor in here that's going to turn the pump. We're going to dictate to the stand at what RPMs to turn this pump. We're feeding it calibration fluid here. We don't use diesel fuel because diesel fuel is not always consistent. We're going to feed this thing a scientifically tested calibration fluid, so we know we've got a static and consistent fluid being fed to the pump. We're measuring return fuel coming off here and housing pressure here. And then this we talked about before, we're feeding boost pressure to the aneroid so we can watch the fuel curve as this thing realizes boost pressures. These are the injection lines that would come out to the injectors in the engine. On the test stand, they go through a calibrated test injector and then back through the measuring unit on the test stand. Unlike some of these older pieces of test equipment, where we're using a graduate or a beaker, this thing is going to take a shorter picture digitally, and we can extrapolate that over time so we can lessen the run time on the stand. This pump has a factory rating. The truck had a factory rating somewhere around 180 horsepower. Clint's initial goal was 350 horsepower, but part of his goal was also safe, reliable horsepower. We can get 350 horsepower out of this pump, but it takes an upgrade to a different head and rotor, and we're not real comfortable putting that in a towing on-road dependable application. We told Clint his different options, and it sounds like dependability, reliability trumped the horsepower in this scenario. Factory full load fuel delivery specification was about 86 cc's, and we told Clint we thought we could probably get a safe 275 horsepower out of this pump. So if 86 was 180, and then we run a ratio on that, we're looking for about 130 cc's. That doesn't always perfectly translate to horsepower, but 130 cc's as far as fuel delivery is concerned would make about 275 horsepower. There's a couple of things that go into horsepower. Fuel delivery is going to increase overall torque and power. Torque is defined as a twisting or turning effort. Horsepower is a calculation of the rate at which work can be done. And horsepower is calculated from both torque and speed. And we also changed the governor spring in this pump. We're going to raise RPM cut off to about 3,200. It's kind of tough to say from here what that would result to on the dyno, but indisputably, we're going to make more power with this pump. We estimate 275 or potentially a little bit beyond that. What you're going to see is the technician fire up the stand. He'll set the RPM on the stand based on different settings of the throttle lever and the boost pressure. We'll walk through what is a test plan. This thing tells us at this RPM and this given set of circumstances, you should see this much fuel delivery. We're also going to watch, this pump has a KSB on the side, so there's a second solenoid here, which is effectively cold start advance. So I don't know what Clint's gonna do, since this is gonna be on a heart transplant truck. I don't know how he's gonna operate that. Some folks don't even worry about it, and she'll just smoke a little bit when you start her up, but you'll watch us, we'll see that. We're gonna give her 12 volts with the test lead, and then on the other side of the rig, there's an apparatus where we're measuring advance.
We're getting 146 for cranking, so got plenty of fuel to start the truck. It's gonna be all right there. Go up there to low idle. We're looking for 20 cc's, so we're right there. The pump's a little cold right now, so our fuel will be up a little bit high, but once it warms up, it'll go down. The KSB we were talking about, it's a cold start advance. What that does is increase your advance timing, which helps eliminate smoke at the beginning. You can see there we went from 0 just by energizing this solenoid. It transfers it moves the housing pressure to the back side of the piston and makes the piston move. So normal operation once the truck's not cold, that's really not in play anyway, but it does work. It is regular stuff. That's the fuel. Right now we don't have any boost pressure going through it. Like I said, we're going to put 1,000 HPAs in it, like 14 PSI. We're getting 130 of fuel, so that's about a 50% increase from what stock is. Then again, on this particular application, we got this one. We wanted the solenoid removed, so we took the guts out. So we've got a manual shut off, which you can hear it there. It went dead. Up here it reads 0, so that's how we'll turn the truck off. We put a bigger governor, get more RPMs out of it. High idle set at 1325. We should be at 80 cc's. We're at here. 3200, which is 1600 on our stand. Governor string, everything's doing what it's supposed to do. Other than that, we'll just check for fuel leaks, but this baby's ready to rock and roll. So that was kind of an abbreviated calibration sequence. This thing had already been run off and it was good to go. We just wanted to bring you back and show you some of the highlights from the calibration process. The actual test plan, the actual process of running this thing off probably takes about a half an hour on the stand. We like to give it a good, long, thorough test, let it come all the way up to temperature. Cold fuel will produce a little bit higher delivery than once the thing's warmed up. It went through the full gamut, got fully up to temperature, and the delivery stayed right up there north of 180. So we're confident we're going to make Clint's goals with this thing. This thing will go back, get a paint job. It'll get serialized so we know who did what to the pump and when. So if there is an issue in the future, we'll know exactly what we did to this pump at that point. I don't foresee that being an issue. We do a fair amount of these. They are a pretty robust and reliable pump.
Here is the solution for Clint's engine. This is a 12-valve engine, VE pump. They're going to transplant it into a mid-late 90s Ford. Couple of things to review here. The pump, when it goes back out, all of these VE pumps, this is a lock time pump. The pump has been set to the installation specifications. A lot of them are top dead center or whatever degrees before top dead center. But currently this pump is locked to the specification. This bolt just drives in and drives up against the drive shaft. Currently lock time, when you get the pump installed, it comes with this tab. So once you're installed, take the bolt out, put the tab behind the bolt. That'll get the bolt up off the shaft. Your pump is free to go. We've seen a number of these not get removed and destroy the bolt, score up the shaft. So just a heads up there. You saw the calibration. Again, we said factory delivery was 86, and that should have made 180 horsepower. We were able to take this pump to 131 cc's of full load delivery, and if we run a proportion ratio out, that tells us we should hit theoretically 274 horsepower. That's not perfect science on the dyno. That won't perfectly add up, but keep in mind we also increased governed engine RPM, so that's going to contribute to the increase in power as well. Took the guts out of the solenoid. Clint's going to have to do something with the KSB, the cold start advance. If they choose to employ that, they'll need a temperature regulated 12 volt supply, toggle switch, or just don't worry about it and know that she might be a little cold natured. Second component is an upgraded fuel injector. This is a 5x12, we would say, so 5 orifices of fuel delivery, 12 thousandths in diameter. Pretty good upgrade over the factory injector. This is brand new Bosch OEM injector. It is really just an injector from a different engine configuration. And in this 12 valve, it would be considered an upgrade. Beyond just the fuel delivery we got from the pump, these injectors will also increase torque and horsepower. And then the final piece of the puzzle, this is a BorgWarner S300, and this is a wastegated unit. This is a 57 millimeter compressor wheel inducer. We get the call every day. They want an S366 or 363. And while we're all about bigger turbos, a bigger turbo in the wrong situation is not an upgrade, it would be a downgrade. This thing needs to spool quickly. The turbo needs to accommodate the level of horsepower we're looking for, and this is a pretty sweet little turbo to handle that. S300 wastegated turbine housing, 57 millimeter compressor wheel inducer. We want the transient response or the lag to be minimal. Again, it's a towing application. The smallest wheel capable of delivering enough air to facilitate the horsepower results in a better driving experience. So this thing is going to light up very quickly. It's going to be wastegated, which will allow it to be appropriate for towing applications. The turbo is factory set to about 25 pounds of boost pressure. Again, safe, conservative boost pressure numbers. This wastegate is not adjustable. However, there are adjustable options for it should they find that they want to increase the boost pressure. Boost pressure is roughly relative to turbo speed, and turbo overspeed is one of the turbo killers. The wastegate is going to ensure this turbo doesn't go into an overspeed and doesn't have any issues. If they are experiencing excessive smoke from these components, that could be an indication that they don't have an adequate source of air. Potentially can combat that to some degree with increasing the wastegate pressure, increasing the boost pressure going to the engine. But higher boost is not always a good thing, right? That's kind of a misnomer out in the world. Boost is only a measurement of restriction. We want a safe, conservative supply of appropriately spec'd air to this engine. If you look on the forums, this is probably too small, right? Everybody needs a 366, but in this situation, that's not the case. This turbo is designed from the factory to be an upgrade to your 94 to 02 Dodge pickups. So the P pump and VP44 pump engine applications. It's spec'd by the factory of being able to support 400 rear wheel horsepower, so another 450 at the flywheel. This dude is more than adequate for the combination we've put together for Clint. Very confident he's going to be pleased with that. Being that this is a 12 valve going into a Ford, the fitment is kind of suspect. We don't know exactly what he's going to get into. But as you've seen, the boys over there will have no issues getting this thing mounted up and plumbed. If you didn't come here from Clint's channel, be sure to go over there and check the boys out, watch them install this hardware, and see how much we're able to wake up this old engine. That is a summary of the power package we've put together for this truck over at CNC Equipment. The million-dollar question, what does something like this cost? This turbo, brand new, authentic BorgWarner unit, out of the box, unmodified, as is this one, $1,366. There are many options out there. We've got them that are more cost effective, or we've got them that are considerably higher in price. This is middle of the road, high quality solution for this exact scenario. The injectors are $72 a copy. Again, brand new, authentic Bosch OEM units. And the pump, with the upgrades, rebuilt, fuel pin, right, the whole spiel, was a $1,300 affair. This dude checks in at $3,100 American dollars. If you find yourself in need of any of these components or really anything diesel related, please don't hesitate to reach out and give us an opportunity to earn your business. You can call us at 800-637-2658. You can email us at parts@areadiesel.com. You can log on to our website at areadieselservice.com, where you'll have the opportunity to chat instantly with a diesel engine expert through the button in the bottom right-hand corner of your screen. Or you can stop by any of our locations in Iowa, Illinois, or Indiana. So that's it. Happy holidays. Thanks for watching.